The Silurian period, which lasted from 443.8 to 419, 2 million years ago, followed the devastating late Ordovician mass extinction. After the extinction event, life rebounded, and the Silurian became a time of remarkable recovery and growth, both in the oceans and, for the first time, on land. The planet's climate stabilized with warm temperatures and rising sea levels, promoting biodiversity. The Silurian marks the beginning of life's colonization of land, as vascular plants and early animals began to emerge from the oceans, creating the foundation for future terrestrial ecosystems. This period laid the groundwork for some of the most critical evolutionary changes in Earth's history. Although the Silurian is known for the rise of life on land, the oceans remained a hub of biodiversity. Following the Ordovician mass extinction, marine life flourished, with coral reefs rebuilding and species like trilobites, brachiopods, and cephalopods thriving once more. One of the most significant developments in the Silurian seas was the evolution of jawed fish, or gnathostomes, which became dominant in marine ecosystems. These early fish were the precursors to the more complex vertebrates that would follow. Meanwhile, coral reefs expanded, creating complex marine habitats that supported a variety of life forms. One of the most groundbreaking developments of the Silurian period was the evolution of vascular plants. Unlike their simpler predecessors, vascular plants had specialized tissues, xylem and phloem, which allowed them to transport water and nutrients, enabling them to grow larger and spread into drier areas. These plants, such as Cooksonia, were small and simple, but they represented the first true land flora. The evolution of vascular systems was a pivotal moment in Earth's history, as it allowed plants to colonize new environments, paving the way for future terrestrial ecosystems. As vascular plants spread across the land, they formed the first simple ecosystems in collaboration with fungi. Fungi played a critical role in helping plants break down minerals and create soil, which enriched the land and allowed for further plant growth. This symbiotic relationship between plants and fungi was crucial to the development of terrestrial ecosystems, as it allowed for more complex interactions and nutrient cycles. These early ecosystems may have been simple, but they set the stage for the vast forests and diverse ecosystems that would follow. The Silurian period saw the first animals make their way onto land. Arthropods, millipedes, scorpions, and other arthropods were among the pioneers that ventured out of the oceans. These creatures developed adaptations like exoskeletons to prevent water loss and specialized respiratory systems to breathe air. On land, these early arthropods likely fed on decaying plant matter and interacted with the growing terrestrial ecosystems. Their colonization of land was a critical step in the evolution of life, as it marked the beginning of animal life on land, paving the way for more complex organisms in the future. As plants and arthropods began to colonize the land, they played a critical role in the formation of soil. The decay of plant material combined with fungal activity and the movement of arthropods began to break down rock and organic matter, forming the first soil. This process created a more stable environment for plants to anchor their roots and allowed for the development of more complex terrestrial ecosystems. The creation of soil was essential for life on land, as it provided a fertile environment where plants could thrive and interact with the growing animal populations. The Silurian period was characterized by a stable and warm climate, with rising sea levels and the formation of shallow seas. These conditions were ideal for the recovery of marine life and the expansion of life on land. The tectonic plates continued to shift, leading to the formation of the supercontinent Euramerica, which influenced the climate and habitats of the Silurian world. This episode explores how these geological changes affected life both in the oceans and on land, shaping the environments that early plants and animals inhabited. The Silurian period set the stage for life's dramatic expansion in the Devonian, but it also left its own lasting legacy. The evolution of vascular plants and the first land animals created the foundation for future ecosystems on land. The rise of early soil and more complex plant life paved the way for the massive forests that would dominate in later periods. The Silurian also saw the recovery and diversification of marine life, which continued to thrive. As the Silurian gave way to the Devonian, Earth was poised for another great evolutionary leap. Don't forget to subscribe to follow the journey into the Devonian, the Age of Fish, as life continues its evolutionary adventure.